Hey guys, so Miss Trejo here. This is going to be hopefully the last video that I'm making for you for quite a while. Like I said in my other videos, I don't really like making these. I like the more interaction that we have during our live classrooms. So this is the video going to be for Friday, September 11th, 2020. So this is the last day you are map testing. Hopefully you all did extremely well on your reading map test. I will see you all Monday during our regular scheduled live sessions that we will follow. So the last couple of days, we have been learning about multiplying rational numbers, right? Where I introduced that little like Dorito chip method, right, that I like to call, right? I'll write it here, right, where we do the little Dorito chip, right? And this helps us figure out what the sign is going to be when we're multiplying either with different signs or same signs, right? All right, so today we're going to do division. So we're going to learn about, well, what about dividing rational numbers, right? We've already done addition. We've already done subtraction. We've already talked about multiplying. The only one we're missing is division. And that's what we're going to talk about today, as well as Monday. So I wanted to put notes, but I'm going to probably wait until Monday when we're live so we can put those notes in our journals together. Okay. So like always, please make sure that you complete your do now. So if you have not done it, I would preferably pause the video, work on the do now, and then come on back and resume the video again. Okay, we are going to need our GoMath book and something to write with. Specifically, we're going to be on page 41 and 42 of our GoMath book. So go ahead and start heading on over there to page 41. And of course, we are going to go ahead and then do our independent practice and then end the day with our exit ticket. Remember, this guy is the one that is extremely important for attendance purposes, right? This one I look at to see if you were here in my class, and I mark you present. If you don't do it, then I mark you absent, okay? So that one is important. Please make sure to do it. We're gonna look at some real world mathematical problems involving the division operation with rational numbers. So again, we could see something with a fraction, with decimals, whole numbers, integers. We are going to be looking at notes. You are going to be writing them in your GoMath book. All right, so I kind of want to take before I continue with the presentation, I do want to look at your Schoology before I actually get into the presentation itself. Okay, so you all right now should be seeing Schoology for Friday, right? Here is week 4. Here's the Friday folder. If you don't have a GoMath book, I've already integrated that into Schoology for Friday. So you'll have those 2 pages, so you don't have to go and worry about them. They're there for you. Here's the do now that you should have done already. You're multiplying decimals. Here's our independent practice that you are going to be responsible for. And then, of course, our exit ticket at the end of the day, okay? So that's basically all we're gonna do today. All right, so now that you know where things are in our folder, per usual, let me go back into our presentation. Awesome, there we go. All right, so again, we're gonna be learning about division with rational numbers, okay? So how do you divide rational numbers? So this is basically going to be looking at that is our question that we're going to be solving in our head later on once we finish this, okay? Remember, for multiplication and division, you are always going to be using that Dorito chip method, okay? Negative, negative, positive. So the same way we used for multiplying rational numbers, we're going to use the same thing here for division, okay, which is pretty cool. So it's basically the same thing, right? So about the signage, okay? Later on about how to actually work them out, that's different. But But right now, when we worry about the sign, that is what we're gonna look at, is the little Dorito chip method, okay? All right, so our learning target, again, we're gonna look at some real world problems involving division with rational numbers. All right, so now we have our explore activity. And like I've said before, I'm always gonna have the page number somewhere in the corner, and we're on page 41. This is in our GoMath book, okay? Please make sure you're already there with me. So let me read explore activity number 1 so you know what we're doing. All right, so it says, this is our little like scenario here. It says a diver needs to descend to a depth of 100 feet below sea level. All right. She wants to do it in 5 equal descents, or 5 equal parts. How far should she travel each descent or each part? Okay, so once again, a diver needs to descend to a depth of 100 feet below sea level. She wants to do it in 5 equal descents. How far should she travel in each descent? Okay, so I think yours on your book is also blank, kind of like this, right? So what I think is important is these word problems, you really need to understand what it is they're telling you and what they're asking you to do, okay? So I think keywords, circling them is really gonna help you understand a lot, okay? She wants to do it in 5 equal descents. How far should she travel in each descent? Okay, so think about an ocean, right? When you are swimming, right? If she wants to go below sea level, right? Like that means she is going down. So that would be, to me, that's a negative number, because again, when you're below sea level, it is a negative number. So I'm gonna write here, negative 100. She wants to do it in 5 equal parts. This is a big keyword, a very big keyword. When you see equal, honestly, this means to divide, right? You're taking a big number, you're going to separate them into equal parts. That means you're dividing, okay? And we want to know how far she traveled in each descent. So we want to know in one part, how much did she go? In another part, how much did she go? In another part, how much did she go? Equally, okay? So like it says, letter A, to solve this problem, you can set up a division problem. Well, they already gave us the numerator, or they gave us the total amount that she dove underneath the sea. So she already, this is our total, right? So she went negative 100 feet below sea level, right? So that's her total. I wanna know, well, she did it in 5 equal parts, right? So that would be my denominator. I'll change it to blue. That doesn't even look like a 5, sorry. There we go, 5. So she did this. This is gonna be our division problem. This is gonna be what we're trying to find. We're trying to take negative 100 and divide it into 5 equal parts. That's what we wanna do, okay? Now, letter B. It tells us we can rewrite division as multiplication. So I think multiplication is probably one of the easiest operations we can do. Division does give some students some problems, but dividing, I think multiplying is another way. So it says here, think. How can we think? Well, some number multiplied by 5 equals negative 100. So we're gonna have to put on our thinking caps and think the inverse of division, which is multiplication. And well, I already know 5 is one of the numbers I'm gonna multiply with. And now I gotta think, well, what is that number that I need to multiply that by? So I know I'm gonna take 5, multiply it by some number that's gonna equal to negative 100. We know that. And then it tells us here, remember for the rules of integer multiplication, if the product is negative, one of the factors must be negative. So I even put here the little Dorito chip, and I'm gonna fill it in as well. I have blue. Let me change it to this pink. Remember, negative, negative, positive. So it's telling us, if we know the product is negative, the product is an answer to multiplication. If I know that that is negative, that means one of the numbers we multiplied before has to be negative, all right? So, and then we're gonna put here, since 5, because that's the number we know, right? I don't like that 5, sorry. There you go. So since this 5 is positive, that means I know the number I'm gonna multiply that 5 with is going to have to be negative, right? Because a negative times a positive is going to give me a negative answer. Remember, we had negative 100. Okay, so that's where they're getting that negative from. Okay, let's go to the next letter. I hope you're filling this out with me at the same time. All right, and now letter D. Know that 5 times some number gives me 100. So using the rules of integer multiplication, you can say that 5 times that number is negative 100. So let's think of this first sentence. We can find 5 times some number gives us 100. So hopefully you all are thinking, well, some number times 5 gives me 100. Hopefully you already know the answer. That gives us 20. 5 times 20 gives us 100. And since we know that the factor has to be negative, meaning this has to be a negative number, that means 5 times negative 20 is 100. And then we can say that the diver, we're answering the question now, we're going to say the diver should descend 20 feet in each descent. Perfect. So, is this the only way that you could have solved this problem here? Absolutely not. Nope. And that's probably, honestly, why I love math so much, is because here's one way to solve it by turning it into multiplication. But we can leave it division because we've been doing T-bow for quite a while. So we do T-bow, right? I'm going to take this right here, negative 100 divided by 5. Remember, we use T-bow. Top in, I'll even put in, I won't put the negative, I won't. Bottom out, 500 by 5, I'm sorry. So now I know, because this is a negative, right? Negative times positive gives me a negative answer. I know that my product is going to be negative. And now we can go and divide. 1 divided by 5, we cannot do, that's too small. 10 divided by 5, or 5 times what number gives me exactly 10? That gives me 2. 5 times 2 gives me 10. 0, bring it down. 0 times what gives me 5? Or 0 times 5 gives me 0, which is 0. And I'm left with a 0 term, which means we have a terminating decimal. Remember, we did this probably like week 2 of distant learning. So that means 100 divided by 5 gives me 20. But remember, we had different signs. We have a negative. So that means that diver went down 20 feet in every descent that she did, or he did. Y'all, she did, the girl. All right, so we get the same answer by using multiplication or division. All right, guys. I'll give you some time to write down this. You can also write down the T-bow part. Hopefully, this one was an easy division one, right? 100 divided by 5 is a really easy one. All right, so I'm gonna delete these. All right, cool. All right, so this one I'm going to have you fill out by yourself. You're gonna use the activity we just did and answer those 2 reflect questions. So number 1, what did you notice about the quotient of the 2 rational numbers with different signs? And number 2, what did you notice about the quotient of the 2 rational numbers with the same sign? Does it matter if both signs are positive or both are negative? So right now I want you to pause the video answer those two questions. Once you answer them, unpause it, and then we're going to look at your answers and my answers, and we're going to compare them, okay? All right, hopefully you went ahead and answered these two reflect questions. So what did you notice about the quotient of two rational numbers with different signs? So basically your answers should say the quotient of two rational numbers with different signs, is what? So if we have one negative and one positive, that means the answer to the division problem, which is the quotient, is negative. And I'm going to change that to red. Okay. So if we have a division problem and we have the numerator as positive, denominator as negative, basically the quotient or the answer to that division problem is going to be negative, right? Different signs, negative. All right. Number two, what do you notice about the quotient if they have the same sign? So does it matter if both are positive or both are negative? Well, not really, right? So we're going to basically kind of use that same sentence here. So the quotient of two rational numbers with the same sign, not different signs, because this one is same sign, with the same sign is what? So if both of them are positive or if both of them are negative, that means our product, I'm sorry, our quotient is positive, right? And our second question, does it matter if they're both positive or they're both negative? Nope, doesn't matter. So we can put here, it does not matter. It does not matter if they are both positive or both negative. Doesn't matter. Either way, we're still going to get a positive quotient. So I'm going to give you an example. So for this one example, we can say -2 divided by, no, I'm going to do a bigger number. Let's do a bigger number. We can say 10 divided by -5, right? So these two rational numbers, I have different signs, right? Positive, negative. The quotient, the answer is going to have a negative answer, right? That's what we're talking about. It's going to have a negative quotient, okay? So an example here, we can have, I don't know, 25 divided by 5, right? Both of the signs are positive, right? If both signs are positive, does it matter? No, it doesn't matter, because that means I'm going to still get a positive quotient. That's one. Another one we can have down here, we can have -12 divided by -3. Both my rational numbers, both my factors are negative, right? Negative divided by negative. That means I'm going to have a positive answer. I'm going to have a positive quotient. So these are examples to go with those two reflect questions, all right? If you did not get them correct or you weren't sure what to do, I really hope you fill this in and you understand now how the signs work with division, okay? Very, very similar to multiplication, okay? All right, so let's look at what we're doing right now. So this is basically how we work on division with the signs, but I prefer, honestly, like I said when we did multiplication, that little Dorito chip method, right? To me, I really like using this. I think it helps you guys understand the different signs and when to use it, okay? So you can definitely copy this down on your journal if you want. I just think this one, my students that I've had previously really like the Dorito chip method, okay? but honestly, totally up to you. It's your notes, okay? All right, and let's look at page 42 in your GoMath book. So page 42. All right, so we're gonna be looking at placements of negative signs in the quotient. So our activity here is, are the rational numbers 12 divided by -4, that's the first one, or -12 divided by 4, and -12/4, are they equivalent? Well, first of all, I need to know, what does that word equivalent mean, right? What does that mean? Well, when I look at the word equivalent, hopefully we all have seen this word before. This is just a big fancy word for, are they equal? Are they the same, right? Basically, that's all equivalent means, okay? So that's just another word for equivalent. Equal, are they the same? Do they have the same weight? Things like that, okay? So first of all, let's look at letter A. So I'm glad that you already have this in your book. I'm just kind of bringing it down into this. So let's see. Letter A, it says, please find the quotient. So quotient means it's just a fancy word for answer to a division problem. Find the quotient, then use the rules that you found in Explore Activity 1 to make sure that the quotient is correct. I'm going to do the little Dorito chip here on the side for those of you that are still kind of struggling with our signs here. Okay. All right, so let's see. Now let's figure them out. 12 divided by -4. Okay, so first let's look at our signs. Positive divided by negative. So if we go here, I'm gonna white it out. Positive divided by negative. What's left on the Dorito chip? Negative. So that means I know I'm gonna have a negative quotient. And now I gotta worry about my signs. Well, what is 12 divided by 4? That's 3. All right. So I'm gonna go back into my Dorito chip and I'm gonna rewrite it for my next problem. I have -12 divided by 4, okay? So now we have negative divided by positive, and I'm left with negative. All right, I know that. Now what is 12 divided by 4? Gives me 3, all right? Now let's look at this one. So if the negative is outside the parenthesis, that means that all you need to do is just add the negative and then do whatever is inside the parenthesis. So that would be 12 divided by 4, which gives us 3. So we found the quotient of those 3 rational numbers, and what do we see? Hopefully you all notice, and that's probably the next question. Awesome, yeah. What do you notice about each quotient? Well, what I notice is that the quotients are all the same number. They are all equivalent, right? So I have -3, I have -3, and I have -3. That means they are equal. They are equivalent to each other. So that's what I'm going to write here. I'm actually going to put here the 3. Now I'm going to put here the quotients are all the same. Or I'm going to use the word up here, equivalent. Okay, awesome. So are the rational numbers equivalent? Absolutely, I wrote it in the sentence anyways, right? So yes, they are equivalent. And now we can think about, how does the placement of the negative sign in rational numbers affects the signs of the quotient? So I'm going to help you out here. So we can put here the sign of the quotient is not affected by the placement of the negative sign. So basically it says, if I have the negative in the denominator, the negative in the numerator, or the negative on the outside with a parenthesis, that's not going to matter. Basically, as long as one of the signs is negative, then your quotient or your answer is going to have a negative integer. Okay, that's all it means. Okay, hopefully that made sense for you all. I really hope so. All right, so now I'm going to clear this board. All right, so now I'm going to go to the next page. You are going to do on your own, so this one is for you. You're going to write the two equivalent expressions for this quotient. So I'm actually going to go back. And I really want for you, if you're kind of lost on, well, what does that mean, Ms. Trejo? I'm really lost. Really pay attention to those three rational numbers that they gave us on Explore activity number 2, and try to use that as a guide for the other two answers that they are asking for each of the question, okay? So I'm going to put here, go ahead and pause the video, work out those two problems. When you have your answer, come on back and we'll check your answers in just a little bit. All right, thank you so much for doing that for me. I truly appreciate it. All right, so we're gonna write two equivalent expressions for each quotient. So I think this one is very similar to the Explore activity, that very first one. So if I go based off of this, I have a positive numerator and a negative denominator. All I'm gonna do is I'm gonna change the sign. So that means I'm gonna have a negative numerator and a positive denominator, okay? Those are equivalent expressions. And then I noticed that I can also use that one with the parenthesis. So if I leave the negative on the outside of the parenthesis, I'm still going to have a negative expression, right? Because this means no matter what I do here, I'm going to have a negative quotient because I have different signs, okay? Number 4, I have a negative 32 divided by a negative 8. So if we think about it, right, both signs are the same. That means I'm going to have a positive quotient because I have the same sign. So if I go based on this, I do know that I have to have the same sign. So if we've already used negative, the one I'm missing is positive. So that means I'm going to take away the negative for both, right? Because positive divided by a positive is still going to give me a positive quotient. All right. Now, if we use this scenario, right, with the parenthesis, I think this one, the third one was kind of tricky. So what you should have done was, yes, have a negative on the outside of the parenthesis, but then either made the 32, oh, that's too small, sorry guys. Either make the 32 negative, or you can have the negative 8 negative, because negative with a negative is going to give us a positive quotient, okay? So either one of those would work for that third answer, and then the middle one, hopefully you all got that one. All right, awesome. Again, thank you so much for working those out for me. I truly appreciate it. All right, so now that's going to wrap up our lesson for today. It was very quick and brief. We'll get into division and the steps I want for us to learn on Monday. So for right now, you're going to log into Schoology, and that independent practice that I kind of talked about at the beginning of the video, you're going to work on. And then, of course, you're going to do your exit ticket that is for attendance, okay? If you need anything from me, if something is not enabled or I need to fix something, please send me a message and I will try to fix it as soon as I can. Please keep in mind that I do math tests all day, and so I may not be able to do it right away, but I will respond as quickly as I can. All right, guys. So please do me a big favor, work on those assignments. Make sure to do your exit tickets. Please make sure to work on your ALEKS topics. I understand we haven't had lab this week, due to math testing, but you are still responsible for your ALEKS topics. Again, you need anything from me, just shoot me an email or a message through Schoology, and I'll get back to you as quickly as I can. All right, guys. I hope you all have a wonderful weekend, and I will see you all Monday live. We'll be back live in our Zoom sessions. I'm excited to see all of you. You have a wonderful, wonderful Friday, a great weekend. Be safe, and I'll see you guys on Monday.